See that it is turning the relays on and off. It is getting up to temp. And if we come over to the web interface that I've got pulled up here, you can see that the sensor is currently reading 200. The target temp is also 200. It climbed up until it got to that 200, and now it's just trying to hold it there. Hi there, my name's Rob, and today we will be converting a manual kiln to a fully automatic digital one. Or even if you already have a digital controller on your kiln, we can upgrade it to one that can, where you will be able to view the firing in real time through a web interface. Okay, it's pretty cool stuff. So let's get into it. First, we're going to go through a materials list. After that, I'll go over the insides of the kiln of this control box here. Try to give you an idea of what you will be looking at when we get into the kiln. Once you take yours apart and you see what's in the inside, hopefully give you a better idea of what you're looking at in there. Okay? Give you a little more confidence for when you go to do it. I'm going to start off with my materials list with a list of absolute must-haves in order to take on this project. If you don't have these, you won't be able to do it. Okay, first off are your most basic tools, okay, like screwdriver, wrench, anything like that, okay? You're going to want just basic tools that you probably already have. In case you don't, they're super cheap. Just go get a kit at Walmart, Amazon, Menards, whatever, okay? You're going to want a laptop or a computer of some kind. You can do it without your own personal computer. However, it will be very difficult because you need to set stuff up on the computer to then transfer it to your Raspberry Pi, which is what we will be using. Raspberry Pi is a little mini computer. But in order to do that, it's easiest to use a computer, like a laptop that you already have, right? So you're going to want that. Next, you're going to need a Raspberry Pi, the thing I just mentioned, okay? It's not a food. It's not an actual pie, all right? It's a little mini computer that is about this big, and you'll be putting a SD card into it that it will read from, and it's just a little computer. That's all. Now, you will need one of the main Raspberry Pis, not the compute modules, okay, but a main Raspberry Pi that has the 40-pin headers on it, okay? The 40-pin headers are the little pins that are sticking out the top of the board, and they are what we will be connecting the wires to so that the different pieces, the different components can communicate and talk to one another, okay? If you get one that doesn't have those pin headers on it, you won't be able to do this project, okay? It won't work. And then you're also going to need a power supply for your Raspberry Pi. A lot of the kits will just come with a power supply. However, some of them don't. Some of them, the listings, you'll see it's just the computer, just the Raspberry Pi. So make sure that you get either a kit that has a power supply or you buy one separately. And then this might be kind of a given, but if you want to view your firing in real time over the internet, well, you're going to need an internet connection, okay? You're going to need some way to view it through the internet, so Wi-Fi or a hardwired Ethernet connection, okay? All right, moving on from the Pi. The next absolute must is a thermocouple, okay? Depending on the model of your kiln, you might already have a thermocouple. If it has a digital controller on it, then you definitely do. I suppose some of the manual types of kilns might have a thermocouple, but if not, you're going to need to order one, okay? Now, there's a lot of different types, and the type that you're going to want to get is dependent on the breakout board that you get for your thermocouple. Now, there are two different types of boards that you can get that are supported by this project, by this program, okay? Both of them are by Adafruit, and they are the MAX 31855 and the MAX 31856. Okay. The 56 supports all types of thermocouples. I am fairly certain. Okay, I'm pretty sure it's a universal. I'll put it on the screen, make sure I'm not giving you misinformation, but pretty sure that it's universal. It supports all of them. The 55 only supports K-type, which for your standard kiln goes up to 10, cone 10. K-type is just fine. Okay, it's great. I would recommend getting the K-type and the MAX 31855 breakout board. Okay, I'd recommend getting those two, but if you already have one of the others, then get the 56. Okay. Do not cheap out on your breakout board for this thermocouple. Okay. Get a name brand Adafruit breakout board. Okay. The price difference is going to be negligible in the long run. And even the name brand, the good quality, reliable Adafruit ones are only like $20 after shipping. Okay. When it comes to firings, kiln firings, reliability and consistency are king. And you do not want to leave your glaze firings up to a sketchy knockoff board. Okay. Get a good quality one. The next thing that you'll need is a solid state relay. They do make non-solid states, which are cheaper, but they are less reliable. They don't last as long, and they can lead to issues where they're not switching properly. Solid state is definitely the way you want to go. Depending on the model of your kiln, again, you might already have one. We'll take a look inside this one, and I'll show you what things will generally look like. But if you have an older style relay, one that's not solid state, I would highly recommend upgrading to a solid state. Okay.
Hi there, Rob from the future here. I misspoke a little bit, and so I just wanted to clarify. For each set of elements that your kiln has, you will need one relay. The reason being is because I'll put a diagram up so that it is maybe a little easier to follow what I'm saying. So the reason being is because the power source, the electricity comes in from your line, and then you're gonna split it off, and it will feed into each set of your elements. And then at the other end of your elements, it'll feed into each relay. Each set will feed into one relay, and then your relays will feed back into your line, back into the power source. Okay? I'll put a diagram up. Hopefully it helps you follow what I'm saying. If you have any questions, just leave it in the comments, and I will do my best to help you. Okay? All right. Thanks.
Next are 1K resistors and BC 547 transistors. Okay. Both of these things, you can find them in bulk pretty much anywhere, like Amazon, any kind of electronic supplier online. You're going to want to get a pack, like a 10 pack, a 20 pack if you want extras, I guess. Because it is possible for them to be bad, for them to be no good. The first transistor that I tried using, it was no good. It wasn't the connector, the collector pin coming off the bottom of it was no good. I don't know why, but you're gonna want more than one because you might have to swap them out. Next on the list are jumper cables, wires, ribbon cable. Okay, you're going to want different wires of different gauges. Okay, and when I say jumper cables, I don't mean the ones like for your car. Okay, these are much smaller ones for little DIY electronics. All right. The jumper cables that I use are 26 gauge, and some of the other wires that I used were like 14 and 16 gauge. Okay. You don't need a lot of different gauges of wires, and you don't need a long length of any wires. If you just even had like 10 feet of whatever gauge, which I don't know if they even come in that short of lengths, but if that's all you have, then that's probably all that you need. Okay. So get some kits with different gauges of wires, different lengths, and you'll be good to go. All right. Next on the list is a breadboard. Okay. A breadboard is a little board with little holes on it that you can stick cables and pins into in order to complete circuits. Okay. You're going to want one of these because it's how you're going to test all your electronics um, and make sure that it's all working before you put it into production. Okay. Um, Again, on something like this, don't cheap out with the cheapest one that you can find with a knockoff brand. Um, get a name brand, good quality one that you can rely on. That way you're not wasting a bunch of time troubleshooting and it just turns out that you had a bad breadboard. Okay. The brand that I went with was a bus board, but there's quite a few name brand ones. Look around and I'm sure you can find them. The last on my list of absolute must-haves is a multimeter. If you are working with any kind of electronics, a multimeter is essentially a must. Okay, it'll allow you to measure the voltage that's running through your currents, through your circuits. It'll allow you to test continuity to make sure that your circuits are making it from point A to point B, that they're continuous. Allow you to measure for resistance on your resistors, make sure that they're working properly, and also you can test the resistance of your coils with them to see if your coils are going bad. So it's good to have for any potter that has a kiln anyways, so you might as well just get one. All right, let's see. Next are nice to haves. These are the types of things that you don't have to have, but will definitely help out. Okay, soldering iron. You don't need a soldering iron, but for the breakout boards, they may or may not come with the pins pre-soldered, pre-connected. There are these little holes on the breakout boards that the pins get put into and then they get soldered in place. If you can find a breakout board that has pre-soldered pins, then obviously you don't need to solder them yourself. But if they don't come pre-soldered, then you're going to have to do it yourself. And in order to do that, you're going to need a soldering iron, as well as solder flux, typically sold in kits. Um, just to give you a heads up so that you know, um, you're probably going to need a soldering iron, but it's not an absolute must depending on if you can find them pre-soldered. And then last on my list of nice to haves is PCB board, which are just little metal plates, little copper boards that have a bunch of little holes in them that you can make hard connections on with solder. So it'll eliminate all the jumper cables and you will solder from point A to point B in order to make your electrical connections. Okay. It's a more permanent setup. You can leave everything hooked up to the breadboard, but it might cause you problems later on. It might not be super reliable long term. If it gets bumped, something could come loose. And so I'm definitely including that in the nice to haves. Not 100% necessary, but making it a more permanent setup by soldering everything will definitely be the way that I'm going to go, and you should probably do it too. All right, moving on from this, let's get up close and personal with the kiln and go through what you might see inside of it, the different parts, the different components, and try to get you a little more confident with taking it apart and working inside of it. Okay? All right. All right. So my kiln is a Duncan Teacher Plus. All right. It says automatic, but it is not automatic. The automatic only refers to the kiln sitter that it has down here that will automatically cut the power once the target cone is reached. It is also equipped with an infinite dial, which works sort of like a clock face, going from low all the way up to high. It has the kiln sitter. It has a timing knob where once you, if you set the timer, once it ticks down to 0, it will also automatically cut the power to the kiln, just like your kiln sitter. And then mine also has this little manual switch to control the bottom set of elements. My kiln in particular has 2 sets of elements. It has a top set, which is these contacts here, and then it has a bottom set, which are these contacts here. All right, so I'm going to disconnect these cables here. That way I can turn this around for you so that you can see inside a little easier. All right, I'm going to go ahead and do that. Okay, we have our control panel taken off of the front. It's pretty easy. All you have to do is use your screwdriver and wrench and disconnect the cables from these points of contact here, from these wires. These are the coil ends, the ends of the elements inside. It fastens on and supplies power to your elements. Okay. Before working with any kind of electrical, anything, cut the power to it. Either unplug it or cut the power at the breaker. Anything like this, anything electrical, unplug it, cut the power. Okay, no debate about it. Let me get this up on the table over there, and I will show you the stuff inside. Let's take a closer look. So, this is your main power coming in from the plug that you put into the socket in the wall. Okay, power comes in here. It goes into this module here, and then everything else in the kiln is powered off of it. Okay, under these two contacts here. Okay. This up here, this is the main control for the infinite dial on the front. If we flip it around, you'll see that little knob there controls the infinite dial and the power supply to your coils. This part here, this is the inside of your kiln sitter. This just slides through the side of your kiln, and a little knob, for your kiln sitter. Okay. This is the back side of the timer. That little timer knob that's on the front, right there, and that ticks down to 0. This cuts the power to the rest of your kiln. Okay. Following down this way, this one in here, that is the relay that's currently in here. Like I said before, I'll be swapping that out with a solid state. This is, I suppose, I don't know for sure, but I'm assuming it's not a solid state because it's older and it doesn't say anywhere on it that it's solid state. So we'll be swapping that out and upgrading it, but that is the relay that's currently in here. These down here are my timers, the timers that control whether the relay turns on the coils, supplies power to them. And that is about it for what's inside of here. Moving over to the electrical side of things, I'll show you the prototype that I have worked up here and give you a better idea of what you're going to be working with before we get into the nitty-gritty, okay? So first we have our Raspberry Pi here. This is our mini computer. It has the pins coming out the side there. You definitely need to get, like I said before, don't get a compute module because it won't have those pins. You need one that has the pins, okay? And then those wires from the pins feed into our breadboard. These white things here are our resistors. There's a couple different styles of resistors. These ceramic ones are rated for a higher temperature, which is why I opted for these. Not super necessary, but I chose to. This is our breakout board for our thermocouple. This one here is the 31855, and this one here is the 31856. Okay, you can see this one has a few more pins on this side here. It has more pins than this one does. This one typically works a little bit easier. It's a little easier to get it set it up and working, and it's a little bit cheaper too. So I would recommend getting this one over that one. However, this one can only accept a K-type thermocouple, whereas this one can work with, come on, focus. There you go. With K, J, N, R, S, T, and E thermocouples. Okay? So you have some options there. And then our thermocouple over here, this is a K-type. As you can see, it took a bit of a tumble. It took a bit of a tumble in between recordings, and some pieces broke off. It will still work just fine, but it doesn't look as nice. So that's unfortunate. Anyways, this is our... Oh, let me... I gotta wrap the camera around here. Let me stand up. Where is it? There it is. That is our transistor there. Transistor has 3 prongs coming off the bottom. Your 3 prongs are the base, the collector, and the emitter. The base connects to your pi. Flip it around. The base connects to the pi. The emitter connects to your ground, which is these on this side. And the collector connects to your relays, which is over here. So that transistor goes through these wires. I upsized to a higher gauge of wire because these relays will be at the kiln, and because of that, they'll be getting hotter than what the rest will be. And so I opted for a higher gauge of wire so that it would be better suited to take the higher temperatures, just to make sure nothing burns out and melts on me. And then, like I said before, you need to have a power source for your Pi. And so this is the power adapter that I've got. It just wraps around the cord and plugs into the wall there. All right, I'm going to leave this video here. My plan is to release this series in a few different videos. And then after I'm completely finished with it, I'll put all of the videos together into one mega movie because it's going to be a pretty long series. Each video is going to have quite a bit to it, and I don't want to overwhelm you immediately. Hopefully, after watching this video, this is something that you're feeling confident with taking on. Like I said before, I'll try my absolute best to explain everything in as much detail and to help you to understand it as best as I can. It was quite a bit for me to go through on my own initially. I definitely had to read through a lot of the issues in the GitHub page to understand like different things, what was going on. So hopefully I can cut a lot of that out for you, all right, and help you get through it easy. Even if you're not planning on going through this project anymore, you watch this video and you're like, well, that's way too much. I don't think I'm interested anymore. No worries. So yeah, thank you for watching. I appreciate it, and I hope you have a great day.